Hello, my name is Vance Farmer. I'm from the Willow Springs Fire Department. I'm here tonight to instruct the hose operations and hose streams class with hopes to obtain my Fire Instructor 1 certificate. I will show you the layout of my class and then I'll bring everybody in and we'll get started. Got my PowerPoint set up. I will have to utilize the buttons on the computer tonight. My clicker has went bad and I am 20 miles from home. I have 4 students tonight that have volunteered to sit in for this class. They'll be sitting here. Bathrooms, ladies' bathroom, the men's bathroom is back here in this nook. We have taken down everything that is considered an obstruction to the class. Of course, we're not going to take down the flags. I have all of the test material and the skill sheets all printed out and ready. So with that being said, I'm going to end this section and start my class. Good evening, everybody. My name is Vance Farmer. I'll be your instructor tonight. Tonight's topic will be hose operations and hose streams. Thank you guys for coming out tonight for this lesson. This facility here is not my department. I'm from Willow Springs, so I'm utilizing the neighboring department. Utilizing this classroom. So if you're not familiar with the building, bathrooms are right here. Women's bathroom up front, men's bathroom in the back. If we had an emergency, tornado, earthquake, anything that might bring this building into jeopardy, we have an emergency route right here. The front door takes you directly outside. This side door right here goes directly outside. This door in the back corner goes out to the engine bay. So keep that in mind. If we've got to get out of the building, utilize this door or the side door. Back door if you plan on being a firefighter. So, what else do we got? How's the air here for you guys? Because we're under an extreme heat wave outside, heat advisory, so we try to cool this classroom off the best we can. If you guys aren't comfortable, voice up and we'll adjust as needed. Okay, well, the way I like to do things is I like to introduce myself and tell you a little about myself. We'll break the ice for each other. I don't know if you guys know each other or not, so I'll start the show. I'll introduce myself, tell you a little about me. We'll start with you and so forth. By the end of the night tonight, we're going to be good friends and we're going to learn some things. So I told you my name is Vance Farmer. I've been in the fire service for about 8 years. I'm currently the chief in Willow Springs. My passion is probably the rescue side of things. Vehicle extrication is kind of my specialty. So hopefully tonight we can figure out if one of you guys are going to be professional hose operators.
My name is Dust Cupits. I'm with Willow Springs Fire Department. I've been on, what would you say, Chief, about 4 years, honestly, going on 5 this October. One thing I really love, everybody else kind of frowns at me for saying it, but I love structural firefighting. It's an adrenaline rush, it's a dangerous job, but it's a rewarding job all the way through. Every aspect of this job is. So that's awesome. Something I'm looking forward to. I get to play with my fire ants.
Yeah.
Lonesy Keaton, I'm the assistant chief here at Pomona. Been fighting fire for 17 years. I took my instructor 1 earlier this year, so just relax, ease through it.
Yeah.
It all works out in the end. So
Thank you for coming for me tonight.
Ian Crusoe, I'm on the fire department. I've only been on for about 2 months, but I like the vehicle extrication also, and going in and getting people out of harm's way.
Yeah. Welcome to the fire service.
Thank you.
I've started off with Pomona Fire Department. I've been on since May or June of this year, and I just like being able to give back to the community if possible.
Absolutely. Thank you guys for the introduction. It's nice to meet you guys. We'll step right into this lesson here. The essentials of firefighting. As you You see it, hose operations, hose streams. Learning objective number 1 will be describe methods used to deploy fire hose. We have several different tactics different ways you can stack the hose on the truck, different ways to deploy it. We're going to work on that tonight and show you guys some tricks of the trade. Right here we've got forward hose lay. Does anybody know what forward hose lay would mean? The new guys probably not, some of you seasoned firefighters. Would you mind giving your input for some of the new guys, and we'll see what we touch on the lesson here.
So the forward hose lay, you're going to take the end of the hose, wrap it around the hydrant so you got more than enough room to work with there, and you're going to leave it there. The driver is going to take off with the truck to the fire. About saying I might be jumping ahead, but reverse hose lay is just the opposite.
Yep.
Forward to the fire, reverse,
Yep.
You're going from the fire.
Good job.
Sorts.
So, the forward lay advantages. The pumper can remain at the incident scene, so hose equipment and tools are available. Pump operator can see fire suppression operation and better react to changes in the fire scene. The communication between the driver operator, the person driving the fire truck, and the person deploying the hose is very crucial. It's very essential they communicate together so the operator's not driving off with the hose before the firefighter gets it
Or has it
secured around the hydrant. Yeah.
Keeps driving.
I'm gonna say go, go, go.
So this is hydrant connection for a forward lay. You'll remove the hose from the apparatus. You'll wrap the hose around the hydrant. You'll anchor the hose, and then signal the driver operator to proceed to the fire. So you wrap it around the hydrant. By anchor, it means get you a sufficient loop around the hydrant. That way, when he goes, it doesn't pull it away from you. It kind of secures it to the hydrant. You throw the tail on the ground and stand on it. That's how you can anchor it. Right here, we have a reverse hose lay. It's the exact opposite of forward. The forward hose lay, he was driving into the fire. He stopped at the hydrant. The firefighter was secured the hose around the hydrant, and they drove to the fire. Reverse hose lay is the opposite. They come from they approached it from the fire, kicked off the hose, and then drove to the water source. The reverse lay disadvantages. It can delay initial fire attack because personnel must first remove tools and equipment and place them at the scene before apparatus proceeds to the water source. The pump operator must stay at the water source, preventing them from performing other essential fireground activities. Reverse lay with attack and supply pumpers. The first arriving pumper starts initial fire attack using water from its tank. The second arriving pumper lays the supply line, connects the hose to its discharge outlet, connects the intake hose, and then begins pumping. Right here is a reverse lay with first pumper working alone for an extended time. You see right here they've got a gated Y where you can run 2 hoses. Review question. Do we now know what the difference is between a forward lay and a reverse lay?
The placement of the apparatus at the scene.
Yes.
Way to put it, actually.
Yeah. What do you think would be the most beneficial, a forward or a reverse lay?
Forward lay.
Yes. Because it gets all your tools and your equipment closer to the work. Your hose is back at the hydrant, your tools and your apparatus and everything, and the operator's closer. He can see what's going on instead of being 500 to 1,000 feet down the street at the water source. He's able to engage a little better from where he's at.
And once he's parked, he's parked.
Absolutely. Discussion question. Provide an example of a situation that would require the use of a forward lay and a situation that would require the use of a reverse lay. Yes.
So, legitimately, I actually think you pretty well covered it whenever you were talking about that. It's more or less what direction you come in from the fire.
Very true.
If, like, this was on fire here, we came in from this way, the hydrant was back behind us, forward lay. But if we were coming in off the highway from this way, that way?
Yeah. Sometimes it can be limited access. There's one way in. If you're going in on a cul-de-sac, if the hydrant's further up into the cul-de-sac from the fire, you have no choice.
So,
So, good job.
to provide an actual example, it's just more or less the direction you're coming in from on the scene.
Yeah. Yep. Anybody else have anything for that? Okay. Learning objective number 2. Describe methods of advancing hose lines. Also, I was going to tell you guys, we'll probably take a break. We've got a few different learning objectives on here. If we get past learning objective number 3, we'll probably take a 10-minute break. So if you have a phone call or something you have to take, feel free to go outside and take it. Just try to get as least disruptive to the class as you can be. Okay, learning objective number 2. Describe methods of advancing hose lines. Deploying pre-connected hose lines. Advancing a AAA hose load. We'll be doing that tonight. The AAA hose deployment. Grab nozzle and bike section for pre-connect. Walk toward the fire until hose is pulled from the engine. Remove hose bike from the nozzle bell. The hose will be tucked up under the nozzle bell. You want to get that out of there. Continue to walk to the fire or flake the hose out for use. Deploying pre-connected hose lines. Advancing a Minuteman hose load. To deploy the Minuteman hose load, you'll grab hose from the nozzle and above. Place that section on your shoulder. Take 3 to 4 steps away from the engine to give some slack. Turn around, grab pull loop of the hose that's still on the engine. You walk towards the fire or objective, flaking hose from pull loop until the hose pulls tight. Begin flaking hose off shoulder until reaching the objective, and then you'll spread the hose out as needed to prevent kinks. Make sure it's not spiraled up, make sure you don't have it looped up. That way when you pump water to it, it comes to you. Note, all right guys, anything that you're going to see in asterisks like this or it's multicolored, I'd probably memorize that. That will probably be on a test, so just keep that in mind. The Minuteman hose load typically deploy with fewer kinks and bends than other loads. What are the 2 methods that can be used to deploy pre-connected hose lines?
AAA and Minuteman.
Good job. AAA and the Minuteman. Any other questions on? Okay. Advancing hose lines. Advancing hose over flat surfaces with no obstacles is simple. Advancing hose lines up or down stairways from standpipes, up ladders, and deep into buildings is more difficult. I'm sure we know why. Uncharged lines are easier to advance. Anybody know why?
Less weight.
Less weight. Water is heavy. It is often unsafe to enter burning buildings with uncharged lines. It's an asterisk. Advancing hose into a structure. A working line drag. Safety guidelines for advancing hose line to a burning structure. Check for and remove kinks and bends. Open the nozzle fully to bleed air and check for adequate flow. Select the desired pattern. Position team members on the same side of the hose line. That's very important. You want to be on the same side. If you're on opposite sides of the hose, the nozzle guy might move one way. It makes everything flow better when you guys are on the same side. When you're dragging the hose, it's one less obstacle to pull around. Advancing hose up a stairway. You keep stairs as clear as possible. Avoid sharp bends and kinks in the hose. If possible, position firefighter at every turn or point of resistance. And that's for the fact that when you start getting up the stairs, it starts pulling tight around the bends. It's getting heavier the further you get in because you're pulling that much more hose. So the more firefighters you have at those obstacles, they're able to pull around them for you. It lightens up your load on the nozzle side. Advancing down a stairway. I probably remember this one, it's an asterisk. Advancing charged hose line is easier, but only recommended when fire is minor or not present. Does anybody know why?
That's their lifeline.
That's your lifeline. If this room was totally blazing, you come in here dragging a hose that's not charged, we're ready for water, you're already getting hot. It's already built on you. It's dangerous. It can cost you the ultimate. So
It can flash and then.
yeah, things change just like that. So you got to pick and choose when to drag an empty hose line. Warning: while advancing an uncharged line is easier, an uncharged line offers no protection if fire conditions worsen. Charged lines are recommended. We just covered that. Ain't no water. You want to have that protection on the water whenever you come in on fire. Advancing down the stairway. Excess hose should be stretched outside the stairway. Firefighters position on the stairs to feed the hose to the nozzle team. Firefighters position at corners and pinch points. Have enough hose to reach the fire. Standpipe operations, high-rise packs. Takes tough guys to do that for a long time. They get heavy. Be alert for pressure relief devices. A gated Y can be used. That's where you can hook up multiple hoses. While connection is made, extra hose should be deployed up the stairs. The method for connecting two attack lines to a standpipe. You can see the standpipe here at the bottom. This is your connection area. See how they left a little slack at the bottom, and they've got slack laying in every stairwell. That keeps it from getting pinched around the corners and stuff when they're going. It makes it easier for them to advance that line. You know, if they need to advance to the fire, they've got enough excess hose laying up the stairs and on the next deck that they can get to that fire and then retreat. Improvising a standpipe. Goofit, you know what that means?
Say, I actually do remember this. So, improvising a standpipe. Feed me a little bit here, kind of help me get going.
Let's go over it. Improvised standpipe. You don't have your water pre-connections already there. You've got to advance your hose. You've got to take your hose up the flights.
Yep.
You have to secure your hose because it's got nothing to hold it. So you're improvising the standpipe. You're utilizing your hose to make the standpipe, and you've got to be able to secure it.
And see, that's where I was on the next one right there with the fire truck. That's what I was starting to get at.
So there's no standpipe here, and this can be utilized if you have a standpipe that fails. I mean, that's an option. You get a lot of apparatus on scene. Your water pressure to that particular pipe could be decreased. You're going to have to deploy your own options. So you drag your own hose in, you get it up to the floor you need it. You can see they've got the solid supports. They've got tie-offs where they're tying that hose off to support the weight. Good job.
We haven't covered that in so long, I can't remember.
A situation that may need to make an improvised standpipe is an earthquake that makes the existing one inoperable. That's one example. When firefighters must improvise the standpipe system, there will be delay applying water to the fire. This delay must be considered in planning the overall firefighting strategy. Is it worth taking the extra time to get this set up? Is this building so far gone that we're not going to be able to save it even if we do all this extra hard work? So want to get that in our pre-planning. What are we gaining? What are we losing here?
Question.
Yes.
So, because I also can't remember this, but they should be strong enough to like support whatever water operation you needed, but can't you also suck them dry too?
Yeah, it depends on the water system. You know, it depends on how that utility is in the ground. The building may have been erected long before the rest of the town below it, so they may have tapped into that main to feed other buildings, so you may not have the volume to that standpipe anymore. It depends on the local building code, local authority having jurisdiction on what was happening with that standpipe. So, but you're correct. You know, things could alter.
Like I said, that we haven't went over this in a while. We don't have any in our jurisdiction. So
Yes. advancing hose up a ladder. It's easier and safer with an uncharged line. We've explained that it's the weight. Does anybody know what a gallon of water weighs?
8.3.
pounds.
8.33.
Yep, just a little over 8 point something. I don't know the exact, I know it's 8 point something. We catch a break, I'll Google that and I'll give you the answer. But it's a little over 8 pounds per gallon. So whenever you're pulling hose up ladders or upstairs, it's very heavy.
Hey, grab my heater too if you would.
Firefighter healing the ladder can feed the hose to those on the ladder. Only one person per ladder section. So if you have a 2-section ladder, you can have a person on the lower section, a person on the upper section. Row hose tools or utility straps can be used for advancement. You can tie them on and use them to pull or use them to anchor the hose off. Hose straps. That's one way to anchor the hose and use it to pull. Do not exceed rated weight capacity of the ladder. If the hose cannot be passed up the ladder without exceeding the load limit, it should be hoisted up. So that's where you factor in your section of hose. Water's 8 pounds a gallon. I'm 200 pounds. Dustin's 220. So we get on that ladder section. We've got a 50-foot section of hose we're trying to get up here. Is all the water in that hose from the entry point to the structure to the ground, plus our weight is going to exceed the rating of the ladder. You got to keep that in mind.
I was saying because just us on our gear would do that.
Yes, yeah. I'm 200 without the gear. So you're adding weight to everything you put on. What are the differences between advancing uncharged and charged hose lines? The weight.
Okay, I was actually about to ask, that's kind of a weird question because it is just that once. But
Well-
she's right. Your uncharged weighs less. It's also more flexible. There's more
Yes.
give.
Yeah, it's
You
easier.
can actually bend it around the corner.
Yes.
More dangerous.
And it is.
Yeah, that's the downfall. It's more dangerous.
And like that charged hose line, the reason why you keep people there at that corner is because you can rub against it and you can rupture that hose right there.
Oh,
So you need to
absolutely,
keep
yeah.
that buffer there.
Yeah, you can drag a fitting through there and possibly loosen up a connection. So you're correct. Both of you guys are right. Learning objective number 3. This will be a good time. Let's go ahead and take us a little break, stretch out a little bit. It is 6:45. Let's come back. 10 minutes, 6:55. Get you guys some drink, stretch out a little bit, and we'll pick up from there. 10 minutes. Yep.
Yeah, I did. I actually, those were legit questions. Because I could have quite worked out like, that was actually like legit questions.
What's a good? Yeah.
I couldn't remember them. Like,
Good refresher, huh?
like,
I've got water here, thank you.
I'll take one if you got one.
Okay, we'll get you one. Yeah.
Yeah, I was like, we don't have them back home in any.
We really don't. Our
The hospital has them.
Yeah, the high rise in West Orange, I think they have.
Yeah.
That's something we're not used to practicing or utilizing. We read it in the books because we don't have that in our jurisdictions.
And,
It's good to keep up on though because we can mutual aid to a jurisdiction that has that.
and it was like, oh, crap, I think you could actually set them right too and crush the tires.
Yes.
So we got sprinkler systems. But yeah, the standpipe, I was like, I haven't had to cover this in a long time. I
Yeah.
covered it for the academy and it's not been a worry on me.
I hope this charging keeps up on this camera. I've got to keep it plugged in full time. That's our new fire department GoPro if you're questioning.
Like, does it fit on like helmets?
Well, we're not going to use it for that. We're going to use
Come
it
on.
for training.
It can be training.
Yeah.
Are you editing all this?
No, it's live action, so don't go dancing.
I wasn't. I was just. But yeah, I did. That was a legit question on the standbys. Is like I haven't we haven't had to cover that or really even talk about that since the academy.
I know, yeah. Well, that's the thing, you know, we go so long outside of that, it's good to have a refresher like this to keep it in your mind. Now you'll remember it next
Well,
time.
and this thing, like some of this, because it applies to our jurisdiction, so you have to learn it and you'll do, but.
Yep.
I'm not like causing a diversion or anything by getting too in depth or.
No, we need the questions. I mean, even me, if I was on that side, I'd be asking questions, because like you're saying, some of this stuff, we've not touched in a while.
Well, and I know some of
That's all
it.
the questions you want.
I also kind of jumped ahead of you there a little bit.
No, you're
Didn't mean to, but.
No, you're okay. Asking questions might make the newer students, you know, it'll make them feel comfortable to engage if they have questions. So, yeah, you're okay. I'm perfectly fine.
Because I mean, we went through the academy together, you taught me this as well, so like, I know kind of where we're heading with it.
Yep. Over here.
Underwear.
Just one for everybody.
Woo! You guys dreading the outside portion?
It's actually, we were just talking about that, it's not terrible.
Is it cooling down?
I mean, it's only 95 now.
Yeah. It's been brutal. Yeah, it's been brutal. I was excited when that rain came in today. I was like, Lord, if it lasted longer, it didn't last long enough to cool anything down.
It said it got down to 72, and I was like, yeah.
Yeah.
Thank you, Lindsay. Yeah, you're welcome. How much is that weight, nerd?
How much?
That weight.
Oh,
Those are 8.33.
Google it. Exactly. It's 8.34. 8.34?
It's 8.3333333333.
Yeah.
Then that would be 8.334.
They just rounded it, it's 8.34.
Are you scientific enough to draw out the formula to figure out the water volume in an 1 3/4 hose, 50-foot
I
section?
used to be able to do that.
I've got the formulas. Yeah, I'm out of practice.
Where you want?
I got spoiled
What
with
you gotta do when you take your engineering certification?
Yes, I got spoiled with calculators now. I used to just be able to write the formulas out.
You gotta do your friction loss and.
I'm about to say, well, I know if you got like a 100-foot section, there's like 50-foot friction loss. That's already cut in half.
I'm talking about your weight, not your flow. Just your overall water weight inside of a 50-foot section. Yeah. A lot of bacon.
Chop BLT.
Is that jerky?
Oh yeah, he reviews jerky. You know they got the Dollar Shave Club?
Yeah.
They got the Dollar Jerky Club.
Oh yeah.
He gets it all sent to him and then he reviews it and
Looks like he's gonna make a massive BLT with
that's what he
jerky.
says. Too much L&T on there for me.
Oh man. That's a heart attack. It's like a 3-pound bucket of mayonnaise.
I bet it tastes good though. We got that Dan over there.
Dan.
He cooks some good food.
Yeah. Well, the camera's charge is holding up. It looks like it's at 89% still, so.
That's good.
Yeah. Yep, I think it's gonna be all right. I think it's gonna hold out.
As long as it has.
I was worried, yeah. I was worried because, it said this battery would only last like an hour-ish total. Oh man, I don't want this thing going dead on me.
I tell you, I hope we can get those hoses put on.
Yeah.
Pretty quick in between.
Yeah. Okay, we got one that,
Wow. You see when it expires?
Okay.
Still in August, aren't we? Expires September 2nd.
Oh, it's close. Okay. All right, guys, you ready? We'll keep class moving forward here. All right, before we get sent to the learning objective number 3 here, if you guys have seen these papers I've got in front of you on the table here, these are our practical skill sheets. If you could, before we finish the lesson here and go outside, if you could just flip those over, sign your name to them, make it legible where it can be understood, sign and date it, and I'll take care of the rest of it for you whenever we get done with practical skills.
Got to do all these.
There's a few on there. We'll get you through it though. All right. Learning objective number 3. Differentiate among types of hose streams and nozzles. Factors that affect the hose stream: the velocity of water and the extinguishing agent, flow rate of water and the extinguishing agent, gravity, wind direction and velocity, air friction, operating pressure, nozzle design and adjustment, and the condition of the nozzle opening. Does anybody know what air friction might mean? You're thinking?
I am thinking. I'm about to say, it's not friction loss.
The wind. Oh, nice.
It kind of is.
The fire we just recently had on that big storage
Right.
tank. Remember we had the aerial set up?
Yep.
The only position we had, we were spraying into the wind and
And it was pushing it back and we wasn't getting,
Yep, so your air friction, yeah.
I'm about to say, that's where your fog pattern really gets affected by it.
Yep. Yeah, because we didn't want to straight stream the material. We wanted to fog it, but whenever you're fogging from the distance into the wind, it was blowing it back around. So we were having to tighten up the stream to penetrate and try not to spray directly on the burning product.
That's why if you can't always fight it at your back, but in that situation,
Yeah, sometimes you're limited. So hose stream uses: applying water or foam onto burning material to reduce the temperature. Applying water or foam into open flames to reduce temperature so firefighters can advance hand lines. reducing the temperature of upper gas layers, dispersing hot smoke and fire gases from a heated area, creating a water curtain to protect firefighters and property from heat. Say the structure next to you. Creating a barrier between a fuel and a fire, and performing hydraulic ventilation. Describing the hose streams to be patterns they form. You got an open fog, you've got a closed stream, nozzles that create the patterns. You've got a smooth bore nozzle that's going to make a big, steady, hard stream. If you've got a fog nozzle, it could open up a big wide pattern where you're not pushing as much water volume, but you're creating a big barrier. Types of control valves and factors that limit a hose stream. The stream quantity and reach. So you take the size of the opening nozzle plus the nozzle pressure, and that gives you the quantity of water flowing from the nozzle. Size of the nozzle opening plus the nozzle pressure is quantity of water flowing from the nozzle. The size of the nozzle opening determines the stream reach. Like I said, if you've got a smooth bore, it's a tighter pattern, you're pushing a lot of water volumes, lunging your water further. A fog pattern, you're not getting this far, but you're creating a bigger water barrier between you and the fire. The hose stream shape. Smooth bore nozzle creates a solid stream. The fog nozzle creates a fog stream or a straight stream. You know, the adjustable fog nozzles, you can do both with it. The NFPA and manufacturers categorize nozzles that produce variable hose steam patterns as adjustable pattern spray nozzles. For the purposes of this manual, we would use the more common term among the fire service, fog nozzle, to describe these devices. NFPA 1963, the standard for fire hose connections, identifies two general categories of hose stream nozzles: the straight tip nozzles and spray nozzles. For this manual, straight tip nozzles will be referred to as smooth bore nozzles, and spray nozzles will be referred to as fog nozzles. The hose stream nozzles. The smooth bore, fog, and broken stream nozzles, they shape the hose stream, they control the water flow, and they create reach. Here's some smooth bore nozzles. Smooth bore nozzle characteristics. Operate at low nozzle pressures, less prone to clogging with debris as it's coming straight through. Can be used to apply compressed air foam. May allow hose lines to kink due to less pressure. Do not allow for selection of different stream patterns. When you pull your belt, what you get is what you get. Here's a flow chart. We can go over every bit of this, but we're not going to. We're going to skip to the next slide. The fog nozzle patterns. You've got your straight stream. You can adjust it down to a narrow angle fog. You can adjust it all the way out to a wide angle fog. Adjustable discharge pattern can provide protection to firefighters with a wide fog pattern, used for a variety of applications. Variety of nozzle choices and manufacturing options can be used to apply certain types of foam. So some of the foam you really got to aerate. And you aerate that by adjusting to a fog pattern where it's got your spinners and your nozzle going. So here's some of your fog nozzles. You've got your basic fog nozzle. You've got the constant gallonage fog nozzle. You've got the constant pressure automatic fog nozzle. And the constant select gallonage fog nozzle. And you guys recognize any of these on your particular apparatus?
I think most people have the end when they're
The constant select?
Yeah.
That's what we have. pretty common. Abrupt changes in the reaction force of the hose line may throw firefighters off balance. Got your pressure up high, got a young guy that's $120, kicks it open, it might kick him back. Automatic fog nozzle flow rates. Got your high flow, your mid-range, your low flow. Water flow adjustments in manual and automatic fog nozzles require close coordination between the nozzle operator, the company officer, and the pump operator. Fog nozzle pressures. Designated operating pressure for most fog nozzles is around 100 psi. 75, 50, or 45 psi. You get less nozzle reaction, greater droplet size, lower density of fog pattern, and less velocity. The water doesn't go as far. What are some differences between smooth bore nozzles, fog screen nozzles? Some of you new guys, do you understand the difference between a fog nozzle now and a smooth bore?
Fog, you can adjust from smooth or a straight string to a fog.
Absolutely.
Bore, you only got smooth, straight strings.
That's right, that's correct. When you, on a smooth bore, when you open the valve, what comes out is what you're getting. So sometimes you can adjust your pressure a little bit to get a little more, but you can't adjust your fog design or anything. What comes out of there is what it's doing. Good job. Hose string patterns. The size, the volume or quantity of water flowing per minute, and the type is the pattern or shape of the water after it leaves the nozzle. String flow rates. Here we've got a master stream. That's the big one. That's when you really want to get a lot of water really far or really high, add a lot of it. You've got your hand line stream. That's where you're advancing the line. You've got a low volume stream. What would be a good scenario for a master stream? We just talked about it a
I'm
second
gonna
ago.
say, we had to hit up high, like
Yeah,
really
yeah.
high. And
Yep, the 30,000 gallon storage tank that was on fire, that requires a good master stream. What would be a good one for a low volume stream?
Dumpster fire.
Dumpster fire.
Dumpster fire.
You're not trying to blow everything out of the dumpster, you're just trying to get the fire cooled off now. So a low stream would be efficient for that. Good job. Extinguishing time, your critical flow rate. This tells you to match your flow to the heat release rate for effectiveness and efficiency. You've got optional flow rate, minimizes extinguishment time and volume of water used. Your increased flow rate brings decreasing improvement in extinguishing time, but significantly increases water used. So this would be considered a solid stream. That's a smooth bore nozzle. When he kicks that bell on, that's the stream that's coming out. That's what they're advancing with. That's what they've got. You've got a fog pattern. If you need to make a barrier, like if you're advancing on a propane tank, you need to make a safety barrier. You would use the fog pattern to keep some isolation between you and the fire. Straight stream. That's if you want some long reach. And then you're broken, like a penetrating nozzle.
I was about to say now, is that, I can't quite see in the picture, is that like a penetrating nozzle? Or
It kind of looks like he's
attic or a basement nozzle?
Yeah, cellar nozzle. Yep. They have the same kind of flow though. It's a broken stream. It just shoots water out and around. The hose stream requirements. You gotta have a pump. You gotta have some hose. You gotta have a nozzle. And you gotta have the agent, the water, the foam, whatever. It doesn't say, but you also have to have a firefighter to run that. So, those are your hose stream requirements. You gotta have all of these to make a hose stream. Solid streams produced from a fixed orifice, smooth bore nozzle, can reach areas other streams might not, can penetrate and saturate burning materials or debris. Reach can be affected by gravity, friction with air and wind, provide large amounts of water quickly, and when solid streams contact the wall or ceiling, the broken stream provides greater surface area to absorb heat and can cool the compartment. Do not use solid streams on energized electrical equipment. I'm sure we know why. It can electrocute you. Solid stream performance. An effective hose stream does not lose continuity until it reaches the breakover point and falls into showers of spray that are easily blown away, cohesive enough to maintain its original shape and required height. Performance depends on velocity and orifice size. The solid stream breakover point. 75% of the stream volume, which is around 10 inches circle, 90% stream volume at 15 inches, that's your velocity and your wind pushing it. The breakover is where you start losing momentum with your velocity. It goes so far that it loses power and it starts falling. That's the gravity pulling down on it. You got your fog streams. They are fine spray of tiny droplets. Exposes maximum water surface for heat absorption. Stream performance characterized by the amount of heat stream absorbs and the rate that the water is converted to steam or vapor. Can be adjusted to the situation. It can be used for hydraulic ventilation, vapor dispersion, and crew protection. That's what we talked about. If you're advancing on propane, you're going to want the protection. That's a good fog. Exposes maximum water surface for heat absorption. And it may be used to cool hot gas layers and hot surfaces. You have shorter reach or penetration than solid or straight streams. Can be more affected by wind than solid or straight streams because the water's not as dense. It can blow around easier. It may disturb thermal layering if applied incorrectly. It may intensify fire by pushing fresh air into the area if used incorrectly. If you advance with the fog over here, say the fire is here and you're trying to dig it, you can advance with the fog there and actually push the fire to another ventilation source. You're pushing that fire into a different area of the structure.
Change flow path.
You can change the flow path. A narrow angle pattern is the highest forward velocity. It's harder to handle. Reach varies in proportion to pressure applied. Your wide angle pattern, I probably remember this one. Less forward velocity, and it's easier to handle. You have shorter reach. So here's some straight streams. You've got a straight stream and then a solid stream. Hose stream limiting factors. You got gravity, that'll limit your hose stream. Velocity loss. Water droplet friction with air, your air drag, and wind. If you're shooting into the wind, it's gonna affect the limit of your stream. How are solid streams, fog streams, and straight streams different from each other? And what factors limit the reach of hose streams? Anybody?
You can only get a solid stream from a smooth bore nozzle. Your straight stream can be from fog nozzle, and it'll go farther than a fog stream.
Yep.
And then everything limits the reach of hose streams.
Yeah.
And
It can be
air.
friction loss, wind air drag. Yeah.
PSI,
Solid.
It can be your PSI, your nozzle choice.
And like
gallonage you're flowing.
Yep.
your solid streams, neat straight streams are more good for attack. Your fog nozzle or fog stream, is better for preservation and protection. Like I assume we're gonna be using the adjustable.
Yes.
Okay, one big advice for the new guys. Right to fight, left for life.
There you go. Yep, right to fight, left for life. Did you hear what he said? Right to fight, you get a straighter stream. The left for life creates the barrier you need to put between you and the fire. That's how you can remember how to adjust your fall rules. Good job, that's a good thing, listen. Learning objective number 4. Explain how to operate different types of hose lines, nozzles, and master stream devices. Operating a small hose line, one firefighter method, small ground cover fire, vehicle fire, rekindle during overhaul, rubbish or trash fire, and fire in outbuildings or sheds. And once again, they've got some hose straps here showing you how you can drag hose. 2 firefighter method, minimum number for attack line in interior operations. We always have the motto 2 in, 2 out. You're always going to work in pairs of 2 for interior operations. Firefighters may apply hose strap or rope hose tool to reduce the nozzle reaction. Seen how you had it kind of tied off there to him. If that has a lot of pressure on it, kicks the nozzle and yanks it, it ain't going to take it away from him. The strap's going to catch it. He can maintain control. Nozzle firefighter holds nozzle with one hand and hose in the other. Hose line rests against the waist and hip. So you stand like this, hold the hose, keep a hand on the bell so you can control your water flow. Your backup firefighter will be on the same side of the hose as the nozzle guy. Holds hose with both hands. Must keep hose straight behind the nozzle operator. If you're behind the nozzle operator, you can't be doing this. You know why? When you're doing this, if the nozzle operator he's aiming for that fire right there, and you yank the hose up, he's hitting the ground now. So it's imperative for the backup firefighter to hold the hose. You help drag the weight. You keep it still right there. Let the nozzle guy do his patterns.
About like a dance. Everybody's moves be in time with each other.
Sometimes you lead, sometimes you follow. Warning: do not direct a fog stream into a ventilation opening during offensive interior operations. If the interior crew is in a room or area immediately beyond the ventilation opening, do not direct a hose stream of any kind into the ventilation opening. Unless you don't want to have any friends, because it gets them mad.
I was about to ask, why is that?
It blocks the fire.
Yeah, you're straight streaming your firefighters. They're not expecting. They're there and doing their work, and you're going to hit them with a straight stream in the middle of the back or in the face shield or something. You could knock their respirator off. You could hurt them, and it really makes them mad. I've been part of that before. It's not. It's dangerous. So if you've got interior guys, that's why it's imperative for communication. So you know where they're at. And if you have to enter the structure as well, you know what your objective is. One firefighter method for large hose line operations. Used for exposure protection or overhaul if a master stream is not available. A firefighter can use a hose strap or rope hose tool to reduce fatigue. You hang onto a big hose, it's a lot of work. It does not permit much maneuvering of the nozzle because it's a lot of weight. Firefighters may need to anchor the hose line. Leaning slightly forward helps control the nozzle reaction. Helps you take the brunt of it whenever it kicks up and pushes you back. Review question. How can firefighters control hose lines?
Hose straps.
Hose straps?
2 people.
2 people?
You can loop it back around yourself and sit on it.
Yep, correct. Good job. Operating nozzles. Each nozzle handles differently at the recommended pressure. Nozzle pattern may affect the ease of operation. Velocity and flow rate cause nozzle reaction. One person can usually operate a nozzle on 1.5 inch or smaller hose line. 1 3/4 inch or larger hose line requires additional personnel. Okay, well, now we're going to talk about water hammer, and it's highlighted there, so I remember that. Water hammer and sudden closing with nozzle. If you're working anything off your, like right here, you've got your fire hydrant that's hooked up to your pumper truck here. When the job's done, you put your wrench back up on there, you're working, you're operating that, you're closing your hydrant. You always get this young gun, he's brand new on service, he wants to get over the hose and then start. So he's gonna crank that operating that. What he's doing, when that thing closes, it's gonna bang! And if it bangs, it can blow your fittings apart underground. Same thing goes with the trucks. If you've got water intaking from your water system into your truck, and you've got your inlet valve, you're filling your tank, you want to shut your inlet valve, your control valve off, you just slam it. It can blow your fittings apart. It can cost thousands of dollars and it makes things inoperable. So you always open and close all your nozzles and valves slowly. When you're closing the hydrant, you just go and go and go. You'll feel when it starts getting pressure and you just snug it shut. On your engines and your pumpers, whenever you're closing them, you just give them pressure until they get to the breaking point and you lock them down. And never bang them. Review questions. How can firefighters operating hose lines combat nozzle reaction? By leaning into it? Yep. We said hose straps. What causes friction loss?
Length of hose.
Length of hose?
Bends and kinks.
Yep.
Rise and falls.
Yep. Up ladders and upstairs. Absolutely. What should firefighters do to avoid water hammer? Open and close valve slowly. Correct. Good job. That's something very important to remember forever. Master stream devices. Usually deployed when fire is beyond effectiveness of hand lines. There's a need for hose streams in areas unsafe for firefighters. You've got a structure that's going to collapse. You don't want to have your guys up there with hand lines. So you're going to master stream it from a safe distance so that you can get out of the collapse zone. Master stream placement. Far enough back to where you're still hitting the objective. Flow a minimum of 350 gallons per minute. Nothing less than 2.5-inch supply lines. Small quick attack devices may be temporarily supplied by 1 2.5-inch line. Third 2.5-inch line required when greater quantities of water are required. And some devices are equipped for 1 4-inch or larger supply line. Large amounts of water accumulate inside structures. Deployment usually requires a minimum of 2 firefighters, at least 1 firefighter positioned at the device, unless it is in a hazardous position. Like I just mentioned, if you've got collapse potential, you don't want to have a firefighter in there. We're going to put a master stream there to get the reach. If the situation is too dangerous, it can be anchored into position. Caution, added water weight from master stream operations increases the potential for structural collapse. And we just said earlier that water's a little over 8 pounds per gallon. We just dumped 40,000 gallons of water into this structure. It's on the floors, it's saturating the walls and the ceilings. That's a lot of added weight on that structure. Elevated master stream devices can apply water to upper stories as a direct attack or supply for hand lines. Can provide exposure protection. Commonly deployed by quints, aerial ladders, and aerial platforms. Review questions. How are master stream devices used?
Big fire.
Big fire. Yeah.
Fire, big water.
You need big water. You've got a spot that requires a lot of water, or you've got a dangerous spot where you don't want to have firefighters with hand lines. So you want a master stream, that way you can get the reach on it to get everybody back.
And then like at really elevated positions.
Absolutely, elevated
Like
positions.
the elevated masters.
Yep.
Ladder.
Yep. Or if you're in New York on the Hudson Bay in one of the boat fire engines, they master stream everything on shore. They pump it right out of the water?
Ish.
Well, that would be the end of the lesson. Does anybody have any questions about this content? You're all looking forward to going out in this 97 or 98 degree weather in your bunker gear and doing some practicals, right?
Yeah.
Everybody looks pumped? I'm
I
pumped.
say, we've been hard.
Yeah. Okay, let's keep the heat in mind, guys, when we go out here. It's very hot, so if we need to take breaks, we'll take breaks as necessary. I don't want anybody to get hurt today. We will have to wear our PPE, unfortunately. So bunker pants, boots, coat, helmet, and gloves. We won't be working around any live fire, so if you want to utilize lightweight gloves, you can. But we've got to have the protective equipment on. We'll do the evolutions. We'll do it one at a time. We'll do the hose deployment. The same team that does the hose deployment will automatically step you into the operating of the nozzle. When we get done with that, if you need a break, we'll come back in here, gear down, and we'll get the next team together for that. So just keep the heat in mind. Don't overexert yourself. If you need to stop, let me know. We will stop until everybody's comfortable to continue. So, sound good? Okay. Well, we will take us a few minute break and get things set up outside. We'll see you out there. All right, so here's the objectives on your skill sheets. We'll be advancing a hose load, pre-connected hose line. The skill objective: the student given 1.5 inch or larger hose wearing PPE, SCBA optional, shall demonstrate advancing a pre-connected hose load from the apparatus. Skill instructions: the instructor shall provide an apparatus with a hose load to the student for purposes of demonstrating advancing the pre-connected hose load from the apparatus. The student shall advance the hose load to an area designated by the instructor. So what we're going to be doing is we're going to be pulling the hose off this truck, and we're going to advance it down towards the car that's back here, the car prop. When the hose stops, that evolution will be done. So the items to be checked: the first one will be the flat hose method.
Well, yeah, but we discussed.
Oh yeah. Oh yeah, we decided we're not doing that. We're going to do the triple layer. Okay. The skill we're doing is triple layer method. Number one, places the nozzle and the fold of the first tier over your shoulder. So you pull that first flake off, sit it on your shoulder. It's got the nozzle attached to it. That first flake will have the nozzle. Pulls the hose load from the bed by facing away from the apparatus and walking toward the area designated by the instructor. So you will be advancing towards that car. Pulls the hose completely out of the hose bed. Drops the folded end from the shoulder when the hose bed has been cleared. Continues to advance to the designated area. After deploying nozzle to designated area, walks the length of the hose, adjusting hose to ensure hose is free of kinks. So when you deploy the hose all the way out to the end, when it stops, you lay it on the ground, you come back all the way to the apparatus and make sure the hose is laying good and flat. But when we put water to it, it doesn't take off, spiral, or kink on you. Okay? So we're going to blend these. We're going to blend these skills since we've got two different things here. One firefighter method. This will be for the hose operation, hose streams, operating a hose line, smooth bore or fog nozzle. Yeah. Okay. The two firefighter method. The skill objective: the student given the necessary equipment, working alone and working as part of a team and wearing full PPE, shall operate an 1.5 inch or larger hose line. The equipment shall be readily available to the student. The student will demonstrate operating a charged hose. So we're going to do the two firefighter method. First objective: grabs and holds the line with one hand behind the nozzle, or grips the nozzle handle and the opposite hand on the nozzle shutoff valve, keeping it within arm's length. Position the second firefighter on the same side as them and at least 1 arm's length behind them, and instructs them to grab the hose and hold it at approximately the same level they are. Number 3, both firefighters prepares to absorb the reaction force of the nozzle and then opens the nozzle valve fully and operates the nozzle flowing water to the objective. If using a fog nozzle, adjust the fog nozzle as necessary to achieve desired stream as instructed by the instructor. What we're going to do here, when you open it up, it's probably going to be on a fog. The objective is to adjust your nozzle to a straight stream and hit the license plate on that car. Once you've hit the license plate, you can close the belt. Number 5, firefighter on the nozzle always maintains control of the hose line with 2 hands. Always maintains control of the hose line with 2 hands. That's weird how they had that twice.
I think that's for the second firefighter when I was looking over it.
Yeah. So the firefighter on the nozzle always maintains control of the hose line with 2 hands. Same for the second firefighter. You always maintain control of the hose line with 2 hands. Closes nozzle valve to stop the flow of water, preventing water handling. So, you guys understand that? You need me to read through them again. If you guys are good, team 1, let's step up and get ready to deploy this hose load.
Yeah, you got it.
Okay. We have limited personnel on hand, so I will be holding the camera and recording as I evaluate. Team 1, after you get the water walked out of that hose, meet me over here and we'll talk about what you done.
Sounds good.
You guys did real good.
Take your gear off.
Yeah.
Yeah, take your coat off and your helmet. Or keep your helmet on.
Okay, come on back over here, Dustin. Let's talk about what you guys. You can go ahead and gear down, take your coat off. That way you can cool off a little bit. Ian, when you got a second. Oh, he's up there. Ian, come down here so we can talk about your practical real quick.
We probably need to be geared up for this video.
Just need to be geared up for the practical. You're okay now. You're cool down. You guys done really well. You missed one step. When you were deploying the hose, you got the hose all the way to the end, and then before before going to the next practical to spray the nozzle, you were supposed to walk all the way back to ensure the hose line was out. Which you had walked it out with him, but the practical stated to walk all the way back. I won't dig you on that because you did walk the line out. You just didn't do it by the procedure. But good job. You guys did a fantastic job.
I hung back a little while back and walked in.
I noticed that. Like I said, that's why I'm not going to dink you for it. You guys done really well. So good job.
Thank you.
Okay, let's help get this other hose restacked back on the truck for team 2.
That is my fault because that's kind of what we do.
Nope, there's no fall here. You did a good job. Yep.
Still recording.
So we're going to restack the hose back onto the apparatus for the next team to do their practical. So it'll be just a few minutes. Bear with us. It is very hot here in southern Missouri right now. We've been in an excessive heat wave for the last week, 110 to 118 with the heat index. So it's 7:30, almost 8 o'clock at night tonight, and it's still 98 degrees. So just bear with us here. We're kind of suffering.
Another thing you can do, keep your feet right up next to it.
Yep.
Kind of show where it's going. We good?
Yep, that's good.
Go forward. I'm just getting a little bit of slack out of it. Are you good? I'm good. Plug right in the middle. I don't think engine 1 had enough room to do this with it. I think we tried it once.
Yeah, we did.
Damn well.
Laying on the deck.
How about now?
You have an open rack like this on top.
That's what I was saying. I think we tried it once with engine 1 and it just didn't work for us when we wanted it.
Limited on certain apparatus of what you do. Team 2, are you guys ready, or do you need a few minutes to cool off? Okay.
Grab my helmet.
You guys need me to reread the skill sheets for you?
I don't think so.
Okay. How about you? You comfortable? Okay. Whenever you guys are ready, get your gear on and we'll get started. We are preparing for evolution number 2 with Team 2. Are you guys good? You need any water or anything? Okay. We'll get through this. We'll get the hose back on the truck and we'll go inside and cool off. Take a little bit of a break before we get into the testing. Good job, guys. Good communication. You guys can take your coats off if you want to cool off while we restack this hose. Once we get it restacked, we'll meet back in the classroom. Guys, once we get this hose restacked, get this truck back in service, we'll meet up in the classroom, okay?
Well, now you still got 2 more people to move.
You want to, is everybody good to do that? Heat-wise, if everybody's...
Ian and I is the only ones that's cold. These guys have cold.
Okay, okay. I was gonna be lenient on that because of the heat.
Okay,
if you guys are good,
I didn't know how you
since
wanted
we've
to do
got such limited personnel here, if you guys are okay with restacking and pulling 2 more times, we can. If you're hot, let's call it. I don't want somebody to get heat exhausted.
Whatever you need me to do.
Okay. It's depending on how you're feeling. If you guys, I'm good with doing it. You guys, the way you work together as teams, it looked like you were confident in what you were doing. The communication was very good. I'm gonna make an executive decision here, and we're just gonna, let's get this hose back on the truck, go to the classroom.
All right.
We're all sweating, it's hot out here. For the safety of the class and the students, we'll call it.
Sounds good, boss.
Thank you, guys. due to the excessive heat, we're just going to consider that paired on that. The firefighters have worked very good. A few of these are well-seasoned firefighters. This instructional video is solely for my Instructor 1 certificate. It's not benefiting them. They'll still have to go through their certification classes to get what they need. So for their safety, we're going to end the practical now and go back to the classroom. All right, guys, we're back inside from the practicals. Good job out there tonight. I thank you guys for toughing out the heat to do this tonight. Good job on the actual practicals too. You guys had really good communication amongst your teams. The objectives were met. So we're getting ready to take our written test here. So a few rules on the written test. Of course, no cheating. That's number one. If you're caught cheating, it's automatic fail. You'll be disqualified. I'll have to ask you to leave. So please, no cheating. Don't use your phones. You keep your phones on the table. Just put them face down. Stick them up the top of the table. That way we can ensure you're not Googling your answers. During test time, some of us go a little faster than others at test. If you fly through it and you're done, bring your test to me. Lay it face down beside me. You can go back to your seat. You can go outside if you want. If you stay inside, be courteous for the other people still testing. So no tapping, no thumping, no playing on your phone if it's beeping. So just keep it courteous for all the other testers. Like I said, when everybody's done, bring your test up, lay it beside me. I will grade it. After I grade your test, I will bring it back to your spot. I will lay it face down, that way you can see your score. Okay? Everybody understand that?
Are we free to leave after that?
No, after everybody sees your score, I'll need your test back. After we get your test back, you're free to go. So, any questions? Okay. If you guys would, before I hand out these tests, bring up your skill sheets for me and just lay them here on the table somewhere. And I'll go through and check off the appropriate boxes for you guys' practical skills. Yep, no, that's not. All right. Thank you.
I think we should turn that AC up some more. Okay. Before we leave, we'll go down and we need to restock that fridge. We need to make sure all the coolers are stocked. Open the fridge, it's easy. Hey, did you guys get that Budweiser beer? Or Budweiser water?
Budweiser beer?
The Budweiser water they hand out?
No, we've never done any of that. Some other departments around that.
You want it? We'll give you a pallet.
Is it still usable?
Oh, it's good. It just takes the pad.
Yep, never interested in that. Okay. You guys start the test at any time, okay? The test is administered. Good luck. 25. When you guys bring your test up here, lay them face down for me, please. Thank you. Somebody done? Let me finish grading these. You guys are just hang tight for a few minutes and we will. Here, you guys can talk now. Let me finish grading this one and we will conclude this class.
You got a roller band?
No.
You suck.
Nobody cares about Little. Oh, here he goes. Look at him. He's got room. Ah. He got 10, 12.
All right.
You guys
What'd you get?
look at your scores.
I got 100.
You guys done very good. Very good. Everybody's passed. Good job. So that will conclude the hose streams and operations skills test and written test. I thank you guys for coming out tonight and doing this with me, for me. You guys are free to go anytime you like. Thank you very much.
You want things, Vance?
Yeah.